So we have a couple of units left to do. And basically, both of them are going to be a lot about fraction expressions, algebraic fractions, which we call rational expressions. I had told you guys on several occasions that in math, when you see the word rational, think fraction. Okay. First of all, we're going to talk about how to simplify them, how to solve rational equations when they equal something, and then look at different types of graphs of rational functions, okay, in addition to another type of function as well. There is going to be a lot of factoring in this unit, which is why I always harp on you really need to know your factoring, okay? Because a lot of what we do when we add, subtract, multiply, and divide rational expressions, and when we solve rational equations, which is what this unit is all about, they have to be in factored form. But first of all, what is a rational expression? Well, it is an algebraic fraction where the numerator and denominator are polynomials. That word should be familiar to you, but what is a polynomial? A polynomial is an algebraic expression that can contain numbers, variables, could also be exponents, but it has to be whole number exponents. That means 0, 1, 2, 3, 4, etc. You can't have fraction exponents. You can't have negative exponents. And it could also have plus or minus signs. So like x plus 8 is a polynomial. It's got a variable, it's got a number, it's got a plus sign, okay? X squared minus 5x plus 14 is a polynomial. X to the negative second plus 5x minus 14 is not a polynomial, because you can't have a negative exponent. You don't have to worry about defining these. The only reason I give these to you like this is so that when I say the word polynomial, you have an idea of what I'm talking about. So what would examples be? Anything like a fraction. So like here's a very simple one, 1 over x. That would be a rational expression. You could have variables in the numerator and denominator. It can get even more complicated. Like so. The point is that it's a fraction. Okay? And there will usually be a variable in the denominator. Most often. Because there's a variable in the denominator, like all of these ones, well, what do we do with these expressions? Well, what we do is we evaluate them. We're given an expression, which is like a formula. We're told what the values of the variable are, and we calculate it. Okay? So for these, I could give you any value of x that I want, except for one. So let's look at this one. X can be any number. So if I said x is 4, the expression is 1/4. If x is 5, the expression is 1/5. There's one number that you can't plug in. What would that number be? Because you can't divide by it. 0, right? So here, x can be any number you want, but it can't be 0. Here, x can be any number you want, but it can't be 2, right? It can be 0 because 0 minus 2 gives you -2. What's that? Oh, sure, absolutely. The exponents can't be negative. Okay? So what do we call those values that you're not allowed to plug in? Non-permissible values, or for short, I always call them NPVs, instead of having to write that out all the time. So what are these non-permissible values? They are values that make the expression undefined. And so what does that mean? That means that the values of the denominators in any rational expression, in rational expressions, can never be equal to 0. Okay? We kind of did this when the very first unit when we talked about radicals, specifically square roots and cube roots, right? We said that there were certain, when we had a radical expression, there were certain values for x we couldn't plug in, okay? And those values made the square root negative, because you couldn't take the square root of a negative number. This is kind of the same thing, okay? So let's look at a couple. Here, all of these are rational expressions because they're fractions. They have variables and numbers, plus minus signs, exponents, nothing negative, no negative exponents, no fraction exponents. So they're all rational expressions. For A, I can plug any number for x in that I want to, except for which one? Right, because if I plug 0 in here, 0 times 3 is 0. 4 divided 0 is undefined. Okay, so we could say it one of two ways. We could say the NPV is equal to 0. Or you could do it this way. X is not equal to 0. Either one of those is an acceptable answer. We don't put x equals 0 because it can't be 0. We say the non-PV equals or x doesn't equal. And remember, it only applies to the denominator, not the numerator. The numerator can be 0. How about this next one? What do you think? Say that again, sorry. Okay, right. So we can figure out what values of x times 2x minus 3 will give us 0. That will give us the NPVs. Isn't this like factored form? And how do we solve in factored form? We make each factor equal to 0. What value of x would make this 0? Just 0. Students have a hard time with that one. And it's the easiest one because you guys overthink it. What value of x would make 2x minus 3 equals 0? Well, I got to solve this. Add 3 to both sides. Divide both sides by 2. That means the non-permissible values, there's 2 of them in this case. It could be 0, because if I plug 0 in here, it doesn't matter what this is. 0 times this is 0. And we can't divide 0. If I plug 3 halves in, it'll make this section 0. And it doesn't matter what this is. 0 times this is 0. I can't divide by 0. So there's 2 of them in this case. So we would say the NPVs are equal to 0 or 3 halves, or if we're going to use the not equal notation, we would say x is not equal to 0 or 3 halves. So there might be more than one value of x that is a non-permissible value. And you can see that if it's in factored form or if you need to factor it. What do you think you'd do with C? How would you figure out what values of x would make the denominator 0? Well, think of it this way. We're trying to figure out what values of x will make this expression 0. What did I just write? A quadratic equation. How do we solve these bad boys? We factor them. So I have to factor. This is a trinomial. Everybody got it? X plus 2, x minus 3. So therefore, x could be -2, because that would make the first factor 0. Or it could be +3, because that would make the second factor 0. So these are the values that would make the denominator 0. So we would say, again, NPVs equals -2 or 3, or x is not equal to -2, 3. How about D? What's different about D than the other 3? Yeah, there's no variable in the denominator, which means there's nothing that will make the denominator 0, because the denominator is always going to be 8. Okay, it'll change the numerator, whatever you plug in for x, but it's always going to be divide 8. So there's no NPVs. Everything is good. So that's one thing that we've got to be careful with when we deal with rational expressions, is non-permissible values. Okay, that was different than when you guys did fractions like in middle school and grade 9, and we've done it since. Okay, where they were just numerical fractions, you didn't have to worry about that. Algebraic fractions, you do. Yeah. Do you? Why didn't you rent a spot from somebody in the gates?
Okay, well, first of all, I only get the car first.
You only get the car, how many, what?
Only on Thursdays.
Only on Thursdays.
Thursday days.
Whoa. Whoa. Do I feel attacked? Wow. Okay. If I keep stalling you, will you get a ticket?
Yes.
Like, when did you park? What time did you arrive here? Did you arrive at 8?
I arrived at like 8:20.
So you still got like 12 minutes. What do you mean?
They're really
Did you just call me bro?
They're really cute. They are.
I know, when I came in yesterday morning, there was one. Well, the guy had parked, like it said no stopping, and he parked right there. Like, so there was a ticket on him, an SUV.
Oh my God,
Yeah. It's like you park right beside the sign that says you can't park in that area. Okay. Further on rational expressions. Not only did we learn how to add, subtract, multiply, and divide them, which we're going to do with these algebraic fractions, okay? When you first studied numerical fractions, one of the things we learned about is how we can reduce fractions. So here we have a numerical fraction. How would you reduce this? That's if you're trying to find, that's if you're trying to add or subtract fractions and you have to find a common denominator. It's not the lowest, highest, common. What do we call a number that divides into another number? That means it's a what of the number? Not multiple, factor. Okay? A factor is a number that divides into another number. A multiple is a number that the number divides into. No, it's not. It is not the same thing. Because if I say the factors of 8, I'm thinking all the numbers that divide into 8. 1, 2, 4, and 8. If I'm talking about the lowest common multiples, or the common multiples, I'm talking about all the numbers that 8 goes into. 8, 16, 24, forever. So we want to find the GCF, the greatest common factor. Which would be what? 3. So we divide both sides by, or we divide the top and bottom by 3. Okay? Or actually, I'm not going to do it that way, because I'll stay consistent. We're going to divide 12 by 3 to get 4. We're going to divide 15 by 3 to get 5. And our answer is 4/5. Okay? But what happens when we've got variables and exponents? Well, it's still the same thing. We're trying to find how much we can reduce the top and bottom by. But the first thing we've got to do notice this time there's 2 variables. Okay? What values of, let's take them each separately. What values of x can I not have that would make the denominator 0? Don't overthink. Just 0. Because if I put 0 in here, 0 squared is 0. 0 times whatever this is still 0. So x can't be 0, right? What about y? Y can't be 0 either. Okay, so we can say this one of 2 ways. We would say the non-permissible value is equal to 0 because it applies to both, or x not equal to 0, comma y not equal to 0. So I need to do that before I reduce. Don't state the non-permissible values after you reduce, because you're going to miss them. Okay. To reduce it, like this. Look at the x's. How many x's could I take out of the top and bottom? 2. So I could take an x squared out of this. What would be left? There's still an x. If I took x squared out of x squared, 1's left. So that's, I reduced the x's like so. How many y's could I take out? Just 1. 1 out of here leaves me 1. 1 out of here leaves me y to the 3 left. That's as far as I can go. So x times 1 up top is x. 1 times y to the 3rd on the bottom is y to the 3rd. Okay. Okay. These next 2. Remember, to find non-permissible values, we always tried to factor if we could, right? Same with reducing. Okay, so the first thing, these top two, we weren't able to factor them. Okay, so factor first before stating the non-permissible values and reducing. I didn't have to worry about that in the above two because there was no factoring done. But once you start seeing multiple terms in the top and bottom, that's usually when factoring is going to happen. So remember the types of factoring you have. You got GCF, you got trinomials, two types. You got difference of squares. Well, these aren't trinomials. So what do you think? GCF, what can I take out of, let's do the numerator. What can I take out? What's the most I can take out of 4x squared and 3x? Just x. What's left after I divide it out? 4x plus 3. How about the bottom? I can take a 2 out. And when I divide 2 out, the other factor is, after I divide everything by 2, 4x plus 3. Whoa. I know you're tempted to start slashing.
No.
But you've got to state the NPVs first. Always the NPVs before you start reducing stuff. So what value of x would make the denominator 0? Well, whatever this, if this works out to 0, that's an NPV. So 4x equals negative 3, x equals negative 3 divided by 4. So the NPV is negative 3 over 4. That would make the denominator 0. Can't have it. Or, like I said, we could just say x not equal to negative 3 over 4. Now, let's start slashing what's common. What do you see that's the same on the top and bottom? I don't see a 3 there. I see 3 as connected with something else. It's in parentheses. You can't take things out of parentheses and cancel them. You got to do the whole, it's all or nothing. And secondly, it's 4x. Yeah, those can go. If I take a 4x plus 3, divide them out of each one, I'm left with 1 and 1. And x times 1 is x on top. 2 times 1 on the bottom is 2. For D, I'm going to have to factor again. What do you think about the top? What kind of factoring? GCF. I can take a 3 out, and the other factor, after I divide both by 3, will be x minus 2. The bottom is a trinomial. And it's not one of the simple ones, because it's got a 2x squared. So this is where we've got to do like the rainbow thingy. Okay, what do these two terms have to be to get me this? 2x and x. These two numbers have to multiply to get negative 10. Give me a pair of numbers that multiply to get negative 10. Negative 5, positive 2. So I know that works. I know that works. But I got to check to see if the middle works. How do I check the middle? I got to multiply the outside and the inside. What do I get when I multiply 2x by 2? or x. Negative 5 times x, negative 5x, together make negative 1x. I need positive 1x. Flip the signs. So 2x plus 5, x minus 2. Okay, so now I've got it in factored form. Now I've got to do my NPVs. What values of x will make the denominator 0? Well, I've got to figure out what value of x will make 2x plus 5 equals 0, and I got to figure out what value of x will make x minus 2 equals 0. Those are my NPVs. So solving this gives me 2x equals negative 5. Divide both sides by 2, I get x equals negative 5 divided 2. That's one of the NPVs. Here it's just x equals 2. So the NPVs are negative 5 over 2 and 2. Or you can write x not equal negative 5 halves, comma 2. Once that's done, go back up to the factored form and start slashing. The x minus 2's can go because that's 1. Nothing else can go. So my final answer reduced is 3 over 2x plus 5. And you can keep the parentheses around the 2x plus 5, but you don't have to, because there's nothing else down there with it. This last one is kind of a special case. Okay. What if I said, I'm not going to worry about the NPV. First of all, what's the NPV? What can't be D? 3. So we know that. So the NPV is 3 for this one. What if I gave you a slightly different one with addition instead of subtraction? What do you think b plus 3 over 3 plus b would be? Nothing? 0? How'd you get 0? Are they the same thing? Really? Write the bottom the other way around. No, it wouldn't. It's plus b plus 3. B plus 3 and 3 plus b are the exact same thing. They're just written in a different order. So I'm actually dividing something by itself. What's anything divide itself? 1. So if it's addition, it's just 1. If it's subtraction, it's different. Yes. Then it's not the same. Because then you'd have b plus 3 over b minus 3. Right? Like if this was negative 3 plus b, to write it the b first, it would be b minus 3. They're not identical. Yeah. So if they're in reverse order but being added, they're the same thing. It always reduces to 1. Not quite so much if it's subtraction between them. And I'm going to show you, okay? Because what I need to do the problem is that they're not written with the b's first. So I'm going to write them both with the b's first. How would I write the bottom with the b first? minus b, because it's a minus b. Nothing's in front of the 3, so it's assumed to be plus. These are not the same, are they? So I can't just cancel it out to 1. However, I can actually factor the bottom. How can I factor it? I can divide -1 out of both of them. I'm going to take out a -1. What's negative b divide -1? B. What's 3 divide -1? -3. Oh, now I've got 2 that are the same, but what's left over? -1. Because I'm showing you why that it works that way. Just, it's not just about tests. No, it's not. So, yes, when you've got a question like this, when they are the same but reversed by subtraction, it'll always reduce to -1. If they are the same but it's addition and they're reversed, it reduces to +1. Okay? So yes, you don't have to show this work, but I don't want to just tell you, say, oh, by the way, when you see this, it always goes to -1. I want to show you why it does. Okay? So now we can go back and we can say, okay, so if I said, what does that reduce to? -1. Because it's subtraction and they're reversed. What does that reduce to? +1. What does that reduce to? Hello, what? Somebody take a leap. Okay. But you're taking a leap. Okay. Are they the same? No. And they're not reversed by subtraction, are they? Which means we can't reduce like this or like this. They're completely different, which means we can't reduce them. So in this one, the answer is a + 5, a - 5. Okay? Don't just assume because they look really close that they're going to reduce to +1 or -1. They have to be a certain way to reduce to -1 or +1. If they're two completely different things, if one's plus, one's minus like that, you can't reduce them. Something important to keep an eye on.